Very good morning. Today we are going to see a circuit take down the circuit, the total current. So in that circuit, we are going to find out what is the total current and total resistance in the given circuit. So find the total current and total resistance in the given circuit that is given. So here one voltage source is there, and here current source is there. Here again resistance is there. Here again resistance is there. Here again current source and resistance is there. But here the question formation itself wrong. So they should not ask what is the total current and resistance. So with respect to what that they need to ask. So here I'm reframing this question. Okay, reframing the given question too. The question of the problem is it should be like find the current supplied by the 5 because here one voltage source is there. Na? So find the total current supplied by the 5 volts and the total resistance as seen by the 5 volts. Total resistance as seen by the 5 volts. So that should be the question. But the question itself given in this question is wrong. So that's why I tried to solve this. So it is the question is given as vague. You should not give the question like a vague because who are solving this question can't they can't even understand. So I'm rewriting the question like this. So now we need to find out what is the current supplied by the 5 voltage source. Um, Total current supplied by 5 voltage source as seen by the 5 so and also total resistance as seen by the 5 voltage source in the given circuit. That should be the question. So what we can do is the above circuit can be redrawn. Okay, so here two current sources are there. That two current source we can make it into one. Okay, so applying the here the Kirchhoff's current law here. So here 5 minus 2 that is 3 amperes. Okay, 3 amperes. Stuff. Okay, so the current direction is like this. Okay, so like that you can calculate the current by simplifying this to current source. Okay, next we'll redrawing the circuit. So here 5 volts is there. So here again 5 volts is there. So here again 3 amperes is there, and again here 5 ohms is there, and again 5 ohms is there. These two 5 ohms are in parallel, so we can reduce it to 1. So parallel means that is 5 by 2 is 2.5. So our circuit can be redrawn like this. Now considering 3 amps as a current source. Okay, so this is considering 3 amps current source as a super node because what is a super node? It is connected through non-reference source. Okay, so that is this 3 amps is considered as a super node. So super node means what? So here if you apply the analysis here, the current in this particular loop is I1, current in this particular loop is I2. Then here you see I2 minus, okay, I2 minus I1 is equal to 3. I2 minus I1 is equal to 3 because here all the voltage source is there. Okay, voltage source is there. And here if you calculate the current, this current is less than this current. So this current is more, 3 amps is more. So I2 minus I1 is equal to 3. Okay, so again simplifying this with respect to minus I1 plus I2 is equal to 3 because I1 we are always taking this first step. I2 is writing in the sequence. Why? Because by solving the equation it will be very easy. Now applying the KVL to the entire circuit, leaving this 3 current source because it is a super node. This 3 ohms is connected as the super node. Okay, so we are considering this 3 ohms as super node. These 2 nodes are the super nodes because two non-reference nodes. Okay, now we are applying the Kirchhoff's voltage law. So if you apply Kirchhoff's, so 5 minus, okay, so minus to plus is raise, minus to plus is raise. So raise is always positive. So 5 minus 5 into I1. Next minus this we need to leave. We need to consider the whole to one second. So here again minus 2.5 I2 is equal to 0. So again after simplifying we'll get as minus 5 I1 minus 2.5 I2 is equal to minus 5. So that we can write it as 5 I1 plus 2.5 I2 is equal to 5. Take this as equation number 2. So now, if you solve this both equation 1 and 2, we'll get I1 is equal to minus 0.33 amperes, I2 is equal to 2.67 amperes. So why here the I1 we are getting minus means this current source, as I said before, this current source is more. If you calculate this current, it is somewhat lesser than this current. So this current is more. So this current is flowing like this. So this current is less. So it is in minus. So minus 0.33 amperes. So I2 is equal to 2.67 amperes in that particular. So now this is the total current. Okay, as seen by the as, we are considering 5 as a voltage source. Now we need to find out the total current supplied by the 5 voltage source. So if you see the this is a 5 volt it's the circuit, no? This is a circuit. This circuit is 5 volt sources there, and here some load is there. One load is there. Okay, say for example, this point we are considering C and B like that. Some load is there. So in that particular load, what is the current flowing is 0.33 amperes, but it is minus. So current is flowing like this from load to source. So my 0.33 amperes direction is like this. So total current supplied by the 5 volt source is 0.33 amperes. That is I1. Okay, that is the total current supplied by the 5 volt voltage source. That is I1, that is 0.33, that is minus 0.33 amperes. Now we need to find out what is the total resistance as seen by the 5 volts. Okay, so we are calculating the total current with respect to 5 volts and also total resistance as seen by the 5 volts. Okay, so 5 volt voltage source that we are finding. So what is the total current supplied by the 5 volt voltage sources? Already we calculated that is minus 0.33 amperes. So R is equal to V by I. So V is 5 volts. Okay, because 5 volt with the 5 volt voltage we are calculating total. So 5 divided by minus 0.33. We can get the answer as minus 15 volts. So RAB is equal to minus 15.15 volts. That is RAB. So minus approximately minus 15 ohms. So RAB is minus 50 ohms means we can write RBA is equal to minus 50 ohms. Because RAB is minus 15 ohms, we can reverse RBA is equal to 15 ohms also we can write. So the total resistance as seen by the 5 volt source is 15 ohms, and also the total current supplied by the 5 volt source is 0.33 amperes. Okay, because from this 5 volts, this is the current is I. So this is the only one current, okay, total current supplied by the 5 sources I1 voltage, that is minus 0.3 amperes. So this is the answer for this particular problem. So sometimes what they will do is they will just give some more current source like this. Here one current source is here one. They'll confuse us. Okay, so by seeing the circuit, we won't attempt because if you see these two current sources there, we won't attempt that particular question. We can easily skip to other questions like. But this question is very easy. But say simple thing is we need to understand the circuit. So understand the circuit, and we need to further proceed and solve at the finally we need to calculate what is the asked. But here the question asked is a little bit confusing. That's why um, here also we can solve, but with respect to nothing there. So that's why I rewritten this question as find the current total current supplied by the 5 volt source and total resistance as seen by the 5 volt source in the given circuit. So this might be the question, but they have given big question. Okay. So anyhow, you need to be careful solving this problem. And a very simple problem you can easily solve. The thing is that circuits looks like a little bit two current sources there. So you may feel like, okay, why to solve this and bit problems. But if you try to solve this, it's very easy problem and easily you can get the answer. Thank you.